Question number 9. A small ball is held at the surface of a liquid oil in a container. Okay. The ball is released from rest. Ball is released from rest. That means what? Initial velocity is 0. And falls through the oil, the ball has a velocity v. Okay. A viscous drag force F acts on the ball. Okay. Now, which graph should show the variation of v with respect to v with v of F? Now, usually when we talk about a ball falling into an oil or viscous drag, the first thing that comes to our mind is it should be terminal velocity. And we think, okay, one of these graphs, this could be the right answer because maybe this is right answer and so on. So both are incorrect. The reason is because what do you mean by viscous drag? Viscous drag or air resistance given to a particle, okay, is nothing but the opposition given to the movement of the object in a viscous fluid. So now this is always seen to be proportional to V, okay, if the object is having at lower velocities, and is proportional to V square when the object is having a higher velocity. Okay, so based on this, now here, this is something like retarding force. This is not possible. This is increasing, that is acceleration, then plateau, and then decreasing. Definitely not. And this is completely, force is reducing. This is also not the right one. So actually speaking, this is the right answer. So A should be your right answer. The force should be proportional to velocity or proportional to V square, and thus you see there is always an acceleration being observed, and thus A should be your right answer.